Welcome to the lecture Matrix Finishing. So after CAD designing and manufacturing either in a milling machine or in a 3D printer matrix prosthetic, we are right now in the chapter prosthetic finalization. The first thing you have to do when you get the matrix prosthetic out of a milling machine, from a milling center or from your 3D printer, you have to do an incoming inspection. And this has basically three different things to do. First of all, make sure that you do an optical control of your prosthetic, which you should do actually with your lenses or even with a microscope to really control if there's any cracks or problems on the connection and in the screw seat. The second thing you have to do is ensure appropriate CAD design parameters and screws are chosen and used during the design process, controlling of this. Functional inspection on the implant model or also on the implant analog is necessary too before sending the final restorations to the doctor. So get more into the details with the visual inspection each prosthetic according to key criteria. So first thing, if we see the prosthetic, we have to control the inner connection of the screw seat of the prosthetics, and also very carefully control the implant connection. And you can see here on the right side two bad examples. You see here a chipping of the screw seat. In this case, you have to repeat the work and do it, mill it again. Here on the right side, you see the milling. The drill was not properly done in the screw seat, so also this would be a criteria where you have to repeat the work. And down here you see the matrix prosthetic connection. Here this is really done maybe with the wrong milling tool, and here everything is very round. For example, this is a good example. There you can see sharp corners in the screw seat, a perfect screw positioning, and also a perfect well milled implant connection. So the second thing you have to control is also if everything is clean. So if you get to the finalization prosthetic where you can see sintered milling powder in the screw channel or in the screw seat, as you can see it here, you have to repeat the work. The good example looks again very straight, very clean. The connection is absolutely clean, and this is how you could start with your finishing process and continue with your finishing process. The second thing you have to control is if all the CAD design parameters were done well. So did the designer choose the right interface, like engaging or non-engaging interface? Did the designer choose the right implant platform? You have to control that. And last but not least, make sure that the right material for the right screw is chosen. You can see that here on the right side again, metals, zirconia and zirconia PMMA screws. Also on the next slide, we can see that a little bit more detailed. And last one point, ensure correct general design of prosthetic restorations. If the design is done in the right size, if the connectors are in the right size, that's very important. So get back to the screws. This is really important. Make sure that the right screws are chosen. The T.25 screws is a titanium or a metal screw. You only use them for metal frameworks or metal prosthetics. Then we have the 2.6 screws. Only use the 2.6 screw for angulated screw channels, and make sure that you and also the dentist has the special screwdriver which only is used for the angulated screw. 2.6 screw, you have to make sure to get the dynamic screwdriver to the dentist to screw retain the prosthetic in the patient's mouth. Second thing here, 2.8 long screw is the main screw to use. This is the screw which we use for zirconia and for PMMA restorations, either 3D printed or milled. And we have also included a 2.8 screw. This screw should be only used when there's very narrow or limited occlusal space, and make sure that mainly the standard screw 2.8L screw is used. Okay, you for finalization of matrix prosthetic have always to use the lab screws. The lab screws are made out of titanium grade 5. They are not sterilized, and make sure that they are never used for a patient situation in patient's mouth. We only use the clinical screws, and here the prosthetical screws have a special design, and you can see that here the concave design of the screw is that you in your finishing process are able to not harm in any case the very fragile or very thin connection, prosthetic connection. You can see that on the picture in this comparison. Here's the lab screw with a big gap to this area, and in the final restoration in the patient's mouth we have no gap here anymore. And so if you have like side forces from the approximal contact point on a model, it's always necessary to use these special lab screws. Okay, there's only one more warning: do never use lab screws in the patient's mouth, only use clinical screws in the patient's mouth. Okay, continuing, protect the matrix interface at any stage during the finishing process. So you can see that here when you start polishing the emergence profile, which you only, by the way, should only polish and never use glazing materials in this area, only to use polished zirconia. You have to protect the prosthetic with an implant analog, as you can see it on these pictures. Inspect the restoration after every working step. So after every working step, make a control. If you have use a lens, make a control of the connection if everything is clean and nicely stable. Make sure that no materials remain or stay on connection on screw seat. So glazing process of matrix finishing is very important too, to always protect your connection, as you see it here in this picture. Then you can always protect the screw channel, that during the glazing process is nothing running inside the screw channel, and make just sure that after glazing, before going into the oven and the baking oven, you have to make sure that your connection is cleaned out and has nothing in the screw seat or no remaining glazing material on the platform connection into the implant. So after the process of glazing, you also have again to control best on the microscope that there's no glazing material, as you can see here on the screw seat remaining, or here you can see a big bubble of glazing material on the screw seat. This shouldn't be, and you can't use a hand drill to drill it out. You have to repeat, in this case, you have to repeat the work and mill a new final zirconia crown. After glazing, check the screw fit in the screw channel and fitting of the crown in the analog. So this is also a handling explanation. So when you use the screw and when you want to use the implant analog, you always make sure that you add the screw into the prosthetic at first, and then with the screw you get actually a nice guiding, a nice parallelising of the prosthetic into the implant analog. And before you start tightening up the screw, make sure by turning the prosthetic into the right connection, into the right index connection, turn it, and then it falls into the index connection, and right after this you are able to fix the crown on the implant analog or in your model. But don't start screwing the implant or tighten up the screw before the prosthetic is in the final position. Here's some samples which you have to know that the handling of matrix prosthetic with caution and analog and models. So here it's just important that the main causes that you know that the main causes of connection damages are torque crown in wrong position, torque crown with lateral collision and on, for example, too tight approximal contact points, engage handling that is not appreciated for zirconia. Always use the correct lab screw for model-based handling. Handle matrix prosthetics with care to avoid chipping or fracture of the connection. This is in your responsibility, and again, please make sure to control after finishing every step under the microscope, or at least under your lens drills. Important instruction for matrix models, because on matrix models it's always at the beginning that the proximal contact points are strong, so make sure that you work gently. As a tip, please use a soft tissue mask and not use the hard blaster or 3D printed materials. Screw retain with lap screws and prosthetics carefully into models, and make sure proximal contact points are not too tight without too much pressure on prosthetic and matrix connection. Last step, 3 sections of the crown must be considered. So on this beautiful picture of a final crown, you can see 3 different areas. The first area is do not touch zone. So this zone here in this area is an area which we have milled with the typical matrix milling strategies. It's perfectly, there should not be any touching, no manipulation of hand drilling tools. There should never be any glazing materials on this area. It just has to be not touched. The area of emergence profile should be only polished material. You can see that polished again with the protection of the connection. And the third third part is the coronal part. Use standard dental techniques, procedures to individualize, characterize, and glaze, respecting respective material properties. So this is how a perfect prosthetic crown for matrix looks after finalization. This is when you can pack the prosthetic into a box and send it to the dentist. Look, again, how important it is to really follow the steps which I just explained. That's the perfect fit on an implant analog, and this is how we should have as a perfect example of a perfect finalized matrix prosthetic. Last but not least, here we have an check for you. Always complete each step of the end control before sending the restoration to the dentist. Please read this end control and make sure you follow each of these steps. See you in the next chapter.